Hello everyone. Today we will study about how these IoT devices, Internet of Things devices, are connected and how they are implemented, how they are communicated, how they exchange data among themselves. Now first we will study about any recap of introduction to communication, how the communication between these hardware devices are should take place and how they exchange the data among themselves. It is being defined. So first we will cover the basics. What is information? What is data? Data is something given, a thing. But knowledge is subject plus data, which is equal to experience. Learning equal to increasing knowledge. Reducing when the knowledge increases, it reduces the uncertainty and improves the outcome. So reducing uncertainty is equal to P A by E, probability of A by E, exclamation mark, equal to PA, probability of A. Information conveys knowledge increments. Information is nothing but it is a knowledge increment. It is measured in bits, having entropy. Now, what is communication? Communication is nothing but conveying information, knowledge. Like this is the diagram how any communication take place. Source, it is the origin from which the communication starts. Source is having the info, then it is goes to the encoder, where from which encodes the information, and the data come out, and the data is transmitted through the channel with help of signal, and channel is having some noise which is to be removed, and it is further received by the receiver, and further it is decoded, and the raw data is sent to the destination, which is to be sent by the source as a message. So this is a whole communication process which takes place in any channel. Encoding and decoding information is converted into data with the help of various encoding and decoding methodologies. Transmission, reception, data is sent through a converted to a signal with the help of energy waves. It is transmitted in the channel channel nothing but it carries and modifies the signal. Data, it carries and modifies the signal, and it is the path on which the data or signal move forward. Signal and channel characteristics. So what is signal? Signal is nothing but an energy wave. You have this is a diagram for signal. Uh, you have seen the ECG diagram of when a heartbeat. It is also a signal, and getting higher and higher, then coming lower, then going upward. It is like a signal. So what is channel? Channel is nothing but a bandwidth having power, noise, and attenuation. So capacity of any channel is equal to B log 2 1 plus PS by Pn bits per second. What is digital signal? Digital signal is nothing but it is a signal which uh, is it in a sequence, and having a particular order, and it repeats after itself. So time discrimination fs is greater than 2 bytes. Amplitude quantization SQ&R signal to noise ratio equal to 2 log 20 log 10 2 की power cube, which is equal to 6.02 q dB. dB is here decibel, the unit of noise. Now, what are the most common media types which are used for the communication purpose? It can be wires like fiber cables, radio bands, etc. So the first one is electrical wires. They are twisted pair cables having a data rate of 10 GB per second, And these are the coaxial cables which are shown in the diagram. Second one, 10 MB per second of data rate. Now the optical fibers. Optical fibers are of two types, single mode and multi mode. In single mode, only the signal tends to go in one direction, and in multi mode, there are many waves sending data at the same time. It is called multi mode fiber. Single mode fiber is having data at 100 TB per second, and a multi mode optical fiber having the 1 GB per kilometer data rate. Now radio bands are also used. Example, ISM bands are also used to transmit the data. Examples are 2.4 by 5 gigahertz band, and it's having data of 300 MB per second. And another is 433 by 668 megahertz, having 64 kb per second as a data rate. We'll study about various IoT wireless protocols like Bluetooth, Zigbee, etc. Now the protocols. These are the rules, guidelines through which any action is performed. Now here comes the communication protocols. By following them, the communication between IoT devices and data exchange take place. Now there are various common network topologies which are used to connect various IoT devices, sensor nodes in devices. First one is P2P. It is the simplest one, and it is node to node, like end to end or system to system. It is the most simplest one. Second one is star or stars. It is the most common in public deployments. And the third one is mesh. It is the most complex one. Example of mesh one is seen there, like in star, all the devices are central node and all the nodes are connected to it. In bus, it is having a common bus line, and to this all the devices are connected. In line topology, all the devices are connected in a linear manner. In ring, all the devices are connected in a ring manner, and they are partially connected with ZOR distance. They are partially connected ZOR, fully connected, and match. These are all a number of topologies in which the manner in which various devices are connected. Now, first, our wireless protocol used for communication is Bluetooth 4 BLE. And it is most common wireless protocol to use for communication. It is our mobiles also. You can see when we turn on the Bluetooth, we can transfer the data among our phones. It is not nothing. It is designed for low power. There are some features of Bluetooth 4. Peripherals advertise themselves. Like when we show on the Bluetooth, we can pair with the devices and send data. The central device initiates two-way connection. It is a two-way connection. It is the get is the diagram for get client and the connected topology used for Bluetooth. It is having peripheral devices connected, peripheral devices all around, and is a central device, phone, tablet, computer, is a get client, and all are the get servers. So this is a diagram for how the Bluetooth services are worked upon. Now next Bluetooth operation is Bluetooth 5. Bluetooth 5 is already here and compatible with Bluetooth 4. Many phones, latest phones like Samsung, Note, iPhone, and some boards are having Bluetooth 5 technology. It is having longer range, greater than equal to 4 meters. It is having 12 dB improved sensitivity, 500 kbps or 125 kbps modes with coded PHY. It is having higher data throughput, approximately equal to 5 times greater than the of Bluetooth 4. Having increased broadcasting capacity, advertising extensions. It is having less congestion, extending advertising payloads. It is having periodic advertising and long range connections. Example for wayfinding, indoor navigation, etc. There are some other wireless protocols used for communication purpose among the IoT devices. These are cellular like 3G, LTE, 4G, 6FOX, etc. Now the IEEE 802.15.4, it is a IEEE, it is a organization which used to convey various rules and guidelines for proper communication. First one is ZigBee. It is most popular in EU, European Union. Designed 244.4 gigahertz of frequency having matched topology used. There are many vendors using it, and it can be used in home automation, smart buildings, meters, etc. Next one is Z-Wave. It is the most popular in US, having 868 megahertz of frequency, matched topology use, having single vendor. It is also used in home automation, smart buildings, smart cities, etc. Now we'll study about TCP/IP protocol. This is the most basic protocol used for the transmission of data over the internet. IP, Internet Protocol. These are IP are private and public addresses used in routing, network address translation, NAT, and firewalls. Hostname DNS. This is a diagram for uh, a NAT router. Having a NAT router is a TCP/IP connection taking place. There is a computers having these IPs connected to a NAT router having gateways as 192.168.0.1 and and these are connected to the internet having the DNS. And the other is TCP and UDP. These are port services used in error control and ordering of packets that is data to be transferred. Now, when we have to take any data, or first we have to send the HTTP request to it. The method used in HTTP requests are get, post, put, delete, etc. Having the headers of accept, what is the content type, what is the encoding used, authorization, how is it authorized, what are the various certificates used, what is the cache control, cookies. These are all headers used in the HTTP request command, HTTP request method. And the body is having application specific XML or JSON file, usually post and put methods only. And this is the example shown in the picture below. Is the first one is the request line, and before the last line is the request header, request message header, and the blank line separates header and body, and then last one request message body is displayed. Now when we are sending data or receiving data, now the second command is HTTP response, hypertext transfer protocol response, and what is the structure and how we have to use it. It is given here is the diagram, and it also first one is the status line, HTTP 1.1 200 OK. It is the status line, and after that date, server, last modified, when is the last modified, the tag, accept ranges, content length, what is the content length, connection is closed or not, what is the content type. This is all response headers used by the HTTP protocol. And there is a blank line, same as HTTP request, which separates header and body, and in last is a response message body. So this was the structure of the HTTP request and response through which the data transfer takes place. Thank you everyone.